All right, let's talk about the unsung hero behind so many of our favorite foods, wheat. I mean, from a perfect slice of bread to a bowl of pasta, its versatility is just incredible. And it all comes down to the amazing science hidden inside a single grain. Seriously, just think about it for a second. A fluffy, airy loaf of bread, a chewy, satisfying noodle, a light, delicate cake. How on earth does one single grain pull all of this off? Well, the answer is in the amazing journey wheat takes from a tiny seed all the way to our kitchens. So, to really understand the magic of wheat, we've got to go small. I mean, really small. We're going to zoom right in on the wheat kernel itself. Because believe it or not, everything that makes wheat so special is packed right inside this tiny little seed. Okay, so if you could crack open a wheat kernel, this is what you'd find. It's made up of three very distinct parts, and each one has a completely different job. You've got the endosperm, which is the lion's share at about 83%. Then there's the bran, making up around 14%. And finally, the tiny but powerful germ at just 3%. Let's look at what each one actually does. First up, you've got the bran. And you can just think of this as the kernel's personal bodyguard, its suit of armor. It's the tough outer shell that protects everything precious inside. It's absolutely loaded with fiber, vitamins, and minerals. This is the stuff that gives whole wheat flour its healthy punch, but it's usually stripped away to make refined white flour. Next, we get to the main event, the endosperm. This is the big one, the starchy powerhouse that makes up over 80% of the kernel. It's basically the seed's lunchbox, a dense package of starch and protein that's meant to be its fuel source. And yep, this is the part that gets ground into that fine white flour we're all so familiar with. And last but not least, there's the germ. This tiny little part is the embryo, the very life force of the seed, holding all the potential to grow into a whole new plant. It's a nutritional gold mine, full of great proteins, healthy fats, and vitamins. So why on earth would we get rid of it? Well, it all comes down to those fats. They're great for you, but they can go rancid, which spoils the flour. So, by removing the germ, flour lasts a whole lot longer on the shelf. Okay, so we know our three parts, right? The bran, the endosperm, and the germ. Now, the big question is, how do we get them apart? This brings us to the next stage, the milling process, where this brilliant separation happens on a massive scale. This whole journey from a hard little kernel to soft flour is a super precise four-step dance. First off, all the wheat gets a thorough cleaning. Then comes conditioning. And this is a really clever trick. They add just a bit of water, which softens up the bran, making it easier to peel off. Next, huge rollers crack the grain open and start grinding it down. And finally, a whole series of sieves separates everything out perfectly: the bran, the germ, and that valuable endosperm. And once that whole separation process is done, you're basically at a fork in the road leading to two very different kinds of flour. On one path, you've got whole wheat flour, which, just like it sounds, uses all three parts of the kernel, keeping all that great nutrition. On the other path is refined white flour, which uses only the endosperm. And that's how you get that super smooth texture and long shelf life. See, it all goes back to the anatomy of that kernel. But, just grinding up the kernel is only half the story. The real magic, the thing that makes wheat the king of grains, well, it's this secret superpower that only gets unlocked when you add one super simple ingredient: water. Okay, so here's the mind-blowing part. Gluten isn't actually in the flour. You can't just find it sitting there. It's something that's created. It's this amazing protein network that literally springs into existence the second you add water and start to mix or knead. It really is a kind of culinary alchemy. So who are the heroes behind this network? Well, it's a power couple of proteins already hanging out in the endosperm: gliadin and glutenin. Think of it this way. Gliadin gives the dough its extensibility. That's the ability to stretch and stretch without breaking. And glutenin provides the elasticity. That's the strength that makes the dough want to snap back into shape. Together, they are the perfect team. So all that mixing you do, what you're really doing is creating this incredible, microscopic, stretchy net all through the dough. And this net has one absolutely critical job: trapping gas. This is the entire reason bread can rise and get that wonderful, airy texture. Without that gluten net, everything would just be flat. All right, so we've built our gluten net. Now what? Well, the whole science of baking is really about helping that net live its best life. It's about bringing in other ingredients to work with the gluten to create that perfect final product. So how do you get those gas bubbles in there for the net to trap? Well, bakers have a few tricks up their sleeve. They can go the biological route with something like yeast, which munches on sugars and releases carbon dioxide gas. Or they can use chemical agents like baking powder, which creates gas through a quick chemical reaction. You can even use physical methods just by trapping air or creating steam.
And to take things to the next level, especially in industrial baking where everything has to be perfect every single time, bakers have a whole toolkit of what they call improvers. They might add something like ascorbic acid to make the gluten network even stronger, or enzymes to give the yeast a little extra food to eat, or emulsifiers to get a softer texture. It's all about fine-tuning the science for a perfect result every time.
You know, this quote from the source material just nails it. The fact that wheat has these unique proteins that can form a stretchy, elastic dough is what puts it in a class of its own. That's it, right there. That's the scientific reason it's the king of baking. So think about where we've been. We started with this tiny, simple seed. We followed it through this high-tech milling process. And we ended with the creation of this amazing, complex protein structure. It's a true transformation from a basic little grain into a scientific marvel. Which leaves us with a final thought. The next time you pick up a slice of bread, just think about that incredible chain of events. The structure of the kernel, the physics of the mill, the chemistry of gluten. Is it just food, or is it a delicious feat of biological engineering? Definitely something to chew on.